Okay, in this class, we want to look at probability. So I've got these nice questions from the University of Zambia. This is MAT2901, Introduction to Probability, mostly done at second year. So we've got, we'll start from question 1. So of 1,000 assembled components, 10 have a working defect and 20 have a structural defect. So there's a good reason to assume that no component has both a defect. So what is the probability that a randomly chosen component will have either type of defect? So looking for a probability that if you randomly pick a component, it will have either a working defect or a structural defect. Okay, so what is the probability that if I pick one, it will have one of the defects? So either working defect or structural defect. Okay, so let's look at how we answer this. Okay, so that was question 1. So we're saying, okay, let us name the events. So let events A and B be the components. Be the components with working and structural defects respectively. Okay, so we're saying the event that you pick something and it has a structural defect is A, and then, working defect is A, structural defect is B. And so the given probabilities are that the probability of having a component with a working defect is 10 out of 1,000. Okay, this is just 1 over 100. And the probability that the picked component has a structural defect is 20 out of 1,000, which is 2 out of 100. Okay, so this is 0.01, this is 0.02. And so now from there, we are told that there's enough reason to assume that the intersection is 0. There's no defect. There's no component that has both defects. So now we are asked to find the probability that if you pick one component, it will either have a working defect or a structural defect. Meaning, we're looking for A union B. That is the probability of A plus the probability of B minus the probability of A intersection B. So the probability of A alone is 0.01. The probability of B, 0.02. For the intersection, it's 0, giving us 0.03. Like that. This is how you answer this question. Okay, so let's go to another one. So let's go to the second one. The second one says, A survey of 200 retail grocery shops reviewed the following income pattern. Monthly income that is under 20,000. The number of shops giving that monthly income of under 20,000 are 102. 20,000 to 30,000 is 61. 30,000 and above, there are 37 shops. The question is, what is the probability that a particular shop has a monthly income under 20,000? So these are the simplest probabilities, okay? The simplest probabilities. So you're looking at under 20,000, and then what's the probability that a shop selected at random has either an income between 20,000 and 30,000 or has more? So what is the probability that it falls in the second category or third category? So the first one is what's the probability that it falls in the first category. So those I'll just put a comment just here. Okay. So for the first one, you're looking at the probability of having the first category. So let me call this A, I call this B, I call this C. So for the first one, you're looking at the probability of having A. That would be 102 over the total, which is 200. Okay, so you just count those. So you get 0.51. Okay, and then for part, so this is part one. So for part two, what is the probability that a shop says that random has either an income between 20,000 and 30,000 or more? So what is the probability that it's A or B? Okay, so if it's A or B, then we're looking at the probability of A plus the probability of B. Okay, which is 61 plus 37 over 200. So you get 0.49, like that. Because even if you separated them, you say it's 61. Suppose you had to say 61 over 200 plus 37 over 200. It's the same because I have the common denominator 200. So I'll still go back and get the same, like that. Okay, so that was just an easy question there. Okay, I hope we picked the concept. Wonderful. Okay, so let's go to question 3. From a sales force of 150 persons, one will be selected to attend a special sales meeting. If 52 of them are unmarried, 72 are college graduates, and 3 over 4 of the 52 that are unmarried are college graduates. So find the probability that the salesperson selected at random will be neither single nor a college graduate. So you want to find the probability that the selected individual will neither be single nor a college graduate. So when you're unmarried, in this case, you are considered to be single. So now it's saying neither unmarried nor college graduates. That's what this means. So let's get to the drawing board. Okay, so now we're here for question 3. So let's again name the events. So let events A and B be events that that a salesperson selected is unmarried and that is a college graduate. Okay, so we're doing this respectively. So that is the probability of being unmarried is 52 out of 150. The probability of being a student is 72 out of 150. The probability of being unmarried and a student at the same time is 3/4 of 52 over 150. Okay. So that's going to be, when you work out the numbers, you get 39 over 150. Like that. So we have these figures. Now we're looking for the probability that the person picked is neither a student, is neither unmarried, nor a student. So that is, we want A complement intersection B complement. Okay, which is 1 minus the probability of A union B. Since we know that we can write this as A union B complement. Okay. It's the same thing if you had used De Morgan's law, it would appear like that. So here we're saying, okay, 1 minus the probability of A plus that of B minus the intersection, which is 1 minus 52 over 150 plus 72 over 150 minus 39 over 150. So we should work out everything and arrive at 13 over 30. Okay, so we're looking at not, because when they say neither, that person should not be a student. That person shouldn't be unmarried. So the person can't even be both. So it's outside the union. So that's why we're doing that. And with the issue of complements, it has come, but we didn't even use much. We didn't even get the complements of each other. We just went straight to the other interpretation of the complement part, which is 1 minus the probability of A union B. I hope that's clear there. Okay, so let's go to the next question. Question 4. Question 4 says, the odds against student X solving a quantitative method a problem are 8 to 6. So 8, so against meaning there's a high chance that the person won't solve it. That is 8 out of 8 plus 6. And the probability that the chance that the person will solve it will be 6 out of 8 plus 6. And the odds in favor of y solving the problem are 14 to 16. So the chance of solving it for the y is lower than that of failing to solve it. So what is the chance that the problem will be solved if they try independent of each other? Okay, so look at this question nicely. So we have the odds against x, 8 to 6, and in favor of y, 14 to 6. So how do we get to the solution for this one? So let's come to the drawing board and say, okay, so we have for x, the odds are 8 to 6. So meaning, so these are odds against. So meaning the probability that x will fail to solve it is actually 8 over 6. And that x will solve it is actually 8 over 6 plus 8. So here it's 6 plus 8, meaning 6 over 14. And in favor of y, we have 14 to 16. So meaning the probability that y will solve it is actually 14 out of 16 plus 14, which is 14 out of 18. Okay? Now we're looking for the probability that these guys, they won't, if they don't work together, okay? Meaning at least one of them will solve it, will solve the problem. Okay, so what does that mean? That means either X or Y will solve the problem, but not together. Okay, so this is the probability of X plus the probability of Y minus X intersection Y. So, so this is going to be the probability of X is actually given as what? It's given as 6 out of 14, 14 out of 30 minus the probability of X intersection Y. The solving, if Y solves it or X solves it, it doesn't affect the other. So the two probabilities are independent. So these we're going to multiply them. 6 over 14 and 14 over 30. So you see, these, they cancel each other. And so we have 6. So I'll be reducing here. Maybe 2 can go there 3 times out of 7, plus 2 there, that is 7 out of 15, minus 3 there out of 10. Okay? So we have this 3 out of 7 plus 7 out of 15 minus 3 out of 10. Yeah. So this is minus 2 actually. I was using, no, I was using 2. Here I used the 3, so it has to be 2. Yeah. Here I could have used 6. Let me use 6. Since 6 can go in itself once, and 6 in 35. Yeah. So for this guy, and so we can say, oh, this is 3 out of 7, plus 15 down, and then 7 minus 3. That is 3 out of 7, plus 4 out of 15. So we need to find the common denominator here. what could be the common denominator? Let me do 7 by 15. So that's 105. So I get 105. So here I'll have 7 into 15. I mean, 7 into 105 is 15. 15 by 3, that's 45. Plus 7 by 4, that's 28. So when I add, what's 28 plus 45? It's actually 73. So 73 out of 105 is a probability that the guys will solve the questions. There's a high chance of them getting if they solve independent of each other. Okay? This is part 1. Part 2 says, let's go and check part 2. Okay. So part 2 says, what is the probability that none of them is able to solve the problem? What is the probability that even if they solved independently, none of them has gotten it correct? So that is the probability that A has failed and B has failed. Remember, they are independent probabilities, so we can multiply them. These guys have failed to solve. So the probability of A failing, I've used A now. Let me bring back my X and my Y. I'm used to A. So X has failed, Y has failed. So X failing, Y failing. Remember, if X and Y are independent, then X complement and Y complement are also independent. So now, if I know the probability of X, obviously I can also know the probability of their complements. So the easiest way is to say 1 minus probability of X and 1 minus probability of Y, which is 1 minus probability of X, so it will just be 8 over 14 multiplied by 16 over 30, just the opposite. So now here we can do the division, is it? So we do 2 here, 4, 2 here, 15. 2 here, 8, 2 here, 7. So it seems like we can't do again. So 4 times that, we get 32 over 105. So that's how we get the probabilities of these guys, none of them getting it correct. So that's how it comes out. Okay. So this was question what? This was question, should be question 5. Let's see. Oh yeah, this was question 4. This was question 4. So this was question 4. Okay, this was question 4. There are so many concepts here that are very much nice. Okay. Interesting, probability is very much interesting. So all that we are required for now is just being able to actually understand the language of mathematics and then bring it into numbers. Okay. So because we are asked what's the probability of them solving independently, what if they solved independently but still failed to get the correct solution? So you pick it out of situations, then you bring in numbers. Okay? That's how it should work. So when you're studying, you study in depth. So here I've used the concept of, okay, when are two events said to be independent? If they're independent, then I can get the intersection by just getting the product. One. The second thing is that if they are independent, then even their complements are what? Are independent. So now I'm able to get the intersection of the complements by just doing the product, because I know that they are also independent if the initial events are independent, and even the complement events are independent. Okay, so let's go to question 5. Let's go to question 5. So question 5. Question 5 says, the probability that a new marketing approach will be successful is 0.6. The probability that the expenditure for developing the approach can be kept within the budget is 0.5. The probability that both of these objectives will be achieved is 0.3. What is the probability that at least one of these objectives will be achieved? Okay. Then there are the events described above independent. So here it comes now. How do I check independence? I just mentioned it in the previous question. I hope you picked it. Okay, now let's check. Let's go to the drawing board. Okay, so question 5. So we have, let's say the first one, we name it A, and the second one, we name it B. Okay, so we'll have the probability of A to be 0.6. That is, what are the events? Let's check the events again. I've forgotten the events. So the first one, now that we have called A, is the event that a new marketing approach will be successful. And then B, that developing will keep the budget within 0.5. Okay. So we check successive, 0.6, developing, kept within, it's 0.5. And that both objectives are achieved is 0.3. Okay. And so what's the probability that one of them is achieved? A or B, meaning A union B. So the probability A plus the probability B minus the probability A intersection B. Quite easy, this one. 0.6, 0.5, 0.3. Okay, that is 0.8. The second, are the events independent? To check if the events are independent, we must check if the probability of A intersection B is actually the probability of A multiplied by the probability of B, like that. That is, probability of A intersection B is already given. So ours is to find the probability of A multiplied by the probability of B. That is 0.6 multiplied by 0.5. So here we are getting 0.3. And 0.3 is the probability of A intersection B. Hence, A and B are independent. Like that. So that's how we check if they're independent. So notice that whether you are told that the probability of A intersection B is 0, and then they ask you about independence, this has not given us the independence statement. We must check if A and that is 0. Then we'll talk about independence. Remember, there is mutually exclusive and also independence. So we must understand the two. Okay. That's Also a good point to take note of. Okay, let's go to question number 6. So this is also a bit light. Let's go to question number 6. Question 6. What does it say? Let's check question 6. Question 6 says, a piece of equipment will function only when the 3 components A, B, and C are working. It will function only when the 3 components A, B, and C are working. So the probability of A failing during 1 year is 0.15. That of B failing within 1 year is 0.05. And that of C failing within 1 year is 0.01. What is the probability that the equipment will fail before the end of the year? Remember, the failing of A affects the equipment. The failing of B affects the equipment. The failing of C affects the equipment can only function if all the 3 are working. So none of them should fail. Should one fail, then the equipment will fail. So what is the probability that the equipment will fail before the end of the year? Okay. What's the probability that the equipment will fail before the end of the year? Okay, so let's go to the drawing board. Okay, so the drawing board we have, I'm going to name some probabilities. So let's say 1, we have the probability of the equipment failing due to A. Okay, that is the failing of A. The probability of the equipment failing due to B. So the failing of B within 1 year is 0.05. The probability of the equipment failing because of C is 0.01, like that. So we want to find the probability of it working. So if it's to work, then these must not fail. Okay, so it should work due to A working, and they're working together. So it should work due to B working. It should work due to C working. So because if one of them fails, then it won't work. Okay, so now what we are given there are failing, and we want working. You see? So we must check. So if I get the probability of it working, then it will be easy for me to get the probability of it failing, because then I'll just get 1 minus the probability of it working. So I want to use that approach. So I'll say, okay, the probability of it working due to A is 1 minus 0.15. The probability of it working due to B is 1 minus 0.05. And then 1 minus 0.01. Like that. So here I'll get 0.85 multiplied by the other one. It's 0.95 multiplied by the other one. It's 0.99, like that, which is when you multiply, now what we get? 0.85 multiplied by 0.95 multiplied by 0.99. So I'm getting 0.799425. Okay, so now I want the probability of it failing within 1 year. Okay, so that will be the probability of 1 minus the one for working throughout the year. So that will be 1 minus 0.799. So I should get, what is 1 minus? So minus 1. So this is 0.200575, like that. Is it? Let me check. Let me be sure. That's 1 minus 0.799. In fact, it's just, yeah, which is, if you round off, you get 0.201, like that. So that's the probability of it fading within 1 year. So you look at what makes it work, what makes it fail. So if one of the equipment fails, then the whole machine has failed. I mean, if one of the components of the equipment fails, then the whole equipment fails. So for it to work, every component must work in that equipment. Okay, so we can easily get to check whether it failed. We'll just get the probability of 1 minus it having worked the whole. Simple. Okay. Is it the same as getting 0.15 by 0.05 by 0.01? What happens if you just multiplied the fading, and see if it failed? The answer would be incorrect. So you must understand what's going on, where we should approach it from at each point. That's the best way of tackling such questions. Okay, so that was question 6. So in the next class, that's when I'm going to look at question 7. But if you really need these videos coming your way, I mean, my contact is 0973 82 5655. So you can WhatsApp me. That's the easiest. So you WhatsApp. And for those from outside comfortable with emailing, you email me at this. Those are not within Zambia. But then if you are within Zambia, this is the contact you can call. And on WhatsApp, if you're outside, you just add a 26. So it will look like this. Okay, so these lessons are offered privately. I can offer these lessons on one-on-one basis. I can offer to a group. I can offer to a class, and the rates are very much affordable. So just contact me, Matthew Takev. You always have enough of it. Okay, enjoy. Thank you.